Hello, this is Miss Moore, and today during chemistry we're going to talk about the atom. Introduction to the atom. Today's essential question: how are the amounts of each of the subatomic particles determined? All right, we'll start with atoms in general. All matter is made up of tiny particles called atoms. Every physical thing that you can think of is made up of atoms. Okay, we're talking about the desk, the table, your pencil, the air, the ground. Pretty much everything except for heat and light are made up of these tiny particles called atoms. And atoms are made up of even smaller particles called subatomic particles. And the three subatomic particles are protons, neutrons, and electrons. You need to know the name subatomic particles and what the three subatomic particles are. And we're going to spend the rest of the lecture talking about protons, neutrons, and electrons. Atoms have two different regions, the nucleus and the outer electron cloud. All right, I'm now going to draw what's going to look like a really ugly picture of an atom. However, it's actually a fairly accurate representation. So let's start with the nucleus. So we'll draw the nucleus in blue here. So the nucleus, color it nice and dark because it's dense. So this is the nucleus. Like what you learned in biology, the nucleus of an atom is in the center of the atom, like the nucleus of a cell is at the center of the cell. However, the nucleus of an atom does not, I repeat, does not contain DNA. Like the atom, like the nucleus of a cell. Okay. In fact, atoms are so small that DNA is made up of billions of atoms. Okay? All right, so we've got the nucleus. Next, let's draw the outer electron cloud. And this is where it gets really ugly. But believe me, it's actually a fairly accurate representation of an atom. So here, all this scribbling here is actually the outer electron cloud. All right, so there's the two regions of the atom. The nucleus in the center, nice and dark and dense, and the outer electron cloud, which is that yellow squiggly stuff. All right, next topic, atomic mass. Mass, you can think of it as weight, okay, how heavy something is. All right, so atoms are really, really, really small. So they have a very small mass. In fact, if we weigh a copper atom, which is a medium-sized atom, not really tiny, a copper atom has a mass of only 1.0552 times 10 to the negative 25th kilograms. Okay, and if you remember your scientific notation, that means a copper atom weighs 0.000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000And because they're so small and it's like a pain to write that many zeros, scientists came up with a unit just for atoms. And that unit is called an AMU, atomic mass units. Okay, and 1 AMU is equal to 1.66 times 10 to the negative 27 kilograms. And the carbon atom is the standard for this measurement. The average mass of a single atom can be found on the periodic table. We'll talk later, actually next lecture, about why we take an average mass. So the average mass of a single atom is found on the periodic table. So in every periodic table, the location could be in a different place. So you always start by looking at the key. Every periodic table will have a key. And this key shows us that the average atomic mass is found at the bottom. So for example, the average atomic mass of beryllium is 9.01. And the units, remember this is a single atom, is AMU. Okay? So the average atomic mass is found on the periodic table. The units are AMU. And in fact, you can grab your periodic tables if you want. And I know I'm letting you fill something in. You can put next to average atomic mass, you can put the units are AMU. Okay? All right, let's start discussing the subatomic particles. Remember, the subatomic particles are the protons, the neutrons, and the electrons. We'll start with protons. So, as you know, I hope, the nucleus is the center of an atom. And protons live in the nucleus. Protons have a positive charge. Protons are positive. The symbol for a proton, in fact, is P+. Okay? Protons are positive. Protons are also very large. Now, I know that probably sounds a little weird because how could protons be large when atoms are small? What I mean is they are large compared to the size of electrons. Okay, so in reality they're tiny, but when you look at them, if you lived in atom world, if you were the size of an atom, protons would be really big. So, in fact, their mass, how much they weigh, is one AMU, which is 200 times greater than the mass of an electron. All right, next up, the next subatomic particle is the neutron. Neutrons are also found in the nucleus. Neutrons are neutral. Okay, they have no charge. Neutrons are neutral. So they are, and we symbolize them as N with a 0, meaning no charge. Neutrons are also large compared to the size of electrons. They're about the same size as a proton, also having a mass of about 1 AMU. Okay, the third subatomic particle is the electrons. Unlike the proton and the neutron, electrons do not live in the nucleus. They are found outside the nucleus in the electron cloud. Okay. And electrons are negatively charged, and when you write them as a symbol, it's E negative for electrons. And electrons are tiny. They are very, very small. They are 200 times smaller than a proton. And their mass is so small, it's negligible. Okay, so an example is, if I were to get on a scale and weigh myself, and let's say the scale said 120, and then I picked up a feather. Think of the feather as being the electron. I pick up the feather and get back on the scale. Do you think the scale is going to change? Or is it going to still say 120? It's still going to say 120 because the feather is so much lighter than me, it basically doesn't make a difference. The feather does indeed have a mass, but it's so small, it just doesn't really count. Okay? And for now, that's all we're going to talk about for electrons. In fact, for the rest of the unit, we're hardly going to touch electrons. Not because they're not very important, but because they are so important, they get a whole unit to themselves. All right, on to the atomic number. As we just discussed, protons have a positive charge, electrons have a negative charge, and neutrons are neutral. So for right now, we're going to be talking about charges, we're going to ignore the neutrons. We'll talk about the protons and the electrons. So here's the deal. Protons are positively charged, electrons are negatively charged. Atoms, however, are neutral. They have no charge. How does that happen? Well, it turns out that for an atom to be neutral, it has to have the same number of protons as electrons so that the charges cancel out. So if you know how many protons an atom has, you know how many electrons an atom has. We don't know the number of neutrons. We'll talk about that later. So we have this thing called the atomic number. The definition of the atomic number, and this is hugely important here, the definition of the atomic number is the number of protons. Okay? Now, because an atom is neutral, the number of electrons will also be the same as the atomic number. However, the actual definition of the atomic number is the number of protons. And next unit we'll talk about that, why that's important. But one more time, the atomic number is the number of protons. Also, all atoms of the same element will have the same atomic number. So, for example, every carbon atom in the world will have the same atomic number, which means it'll have the same number of protons. Every carbon you run into will have the same number of protons. Okay? So So the atomic number can be found on the periodic table. And so if we go back and start with our key, remember, again, every periodic table is set up a little differently, so we need to find the atomic number, and it says it's the top number. So we'll go back to our friend beryllium. So the atomic number for beryllium is 4. So every single beryllium atom you ever see will have 4 protons. Okay. Every single chromium will have 24 protons because its atomic number is 24. And every single sodium atom will have 11 protons because it has an atomic number of 11. So now, let me ask you this. If you run into a sodium atom, you know it has 11 protons. What else do you know? If it's a sodium atom and it has 11 protons, it also has 11 electrons. Okay. The atomic number can also be written with the element symbol. Okay, so what you have here is you have the element symbol, and this guy right here is carbon, and written down below it and to the right, to the left. It's too bad I don't know my right and left. So below and to the left is the number 6. And if we go back and look, that's not on there, never mind. The atomic number for carbon is 6. All right, we're now going to talk about mass number. Mass number, or the atomic mass, the definition is the number of protons plus the number of neutrons. Now, if you remember, we talked about a few minutes ago that when we're talking about looking at the periodic table, we can find the average atomic mass, and that number is written on the periodic table. And it's also, if we go back and look, let's find one. You can look at the atomic mass of, for example, iron, which is 55.85. Okay, but that's the average atomic mass. They took a whole bunch of iron atoms, put them together, weighed them, counted how many they weighed, and divided by that number, and they came up with 55.85. Okay, but when we're talking about the atomic mass of a single atom, just one atom, it's going to be the number of protons plus the number of neutrons. The reason that works, if you remember, a proton weighs 1 AMU, and the neutron weighs 1 AMU. Okay, so if you have an atom that has 1 proton and 1 neutron, its mass is going to be 2 AMU. Okay, so again, we're talking about an individual atom. We will talk about tomorrow why average atomic mass may be different. Okay, when we're talking about mass number of a single atom, you cannot have a fraction. You cannot have a decimal. You can't have half a proton or half a neutron. It just doesn't work. Okay, so the formula is written here. Atomic mass equals the number of protons plus the number of neutrons. So now, if you know the mass number and the number of protons, you can figure out the number of neutrons. And we'll do that in a minute. Okay. The mass number, or the atomic mass, can also be found on the periodic table. Remember, however, that it's an average. So what you're going to do is round, because you can't have a fraction. So when we're doing some mathematical calculations that I'm going to show you in a minute, you need to round to the nearest whole number. Okay? Round to the nearest whole number. Okay, so the atomic mass can also be written with the element symbol. So we have carbon here. Its atomic number is 6. And its mass number is 12. And remember, mass number means it's also the number of, no, not mass number, sorry. Atomic number is the number of protons and also the number of electrons. All right, so now let's try some practice problems. We'll start with nitrogen. So let's go to the periodic table and see what we can find out about nitrogen. So nitrogen is located here. We know it has, and we look at this 7. It has an atomic number of 7, and it has a mass number of 14.01, which we're going to round to the nearest whole number, which would make it 14. All right, so let's go fill that in our table. We said it's had atomic number of 7. and an atomic mass of 14. All right, so from that information, we need to figure out the number of protons, neutrons, and electrons. So, how do we figure out the number of protons? Well, the number of protons is the same as the atomic number. How do we figure out the number of electrons? That's the same as the number of protons. And now, how do we figure out the number of neutrons? We just learned a formula. Mass equals number of protons plus number of neutrons. We know the mass is 14. We know the number of protons is 7. So now we just need to figure out the number of neutrons. So to solve this problem, we're going to subtract both sides by 7. And that gives us the number of neutrons, which is 7. Okay, let's try another one. Why don't you hit pause, try to do this without me, and then hit play and see how you did. All right, so sodium has, sodium's over here, it's an Na, a little confusing. It has an atomic number of 11 and a mass of 22.99, which we're going to round to 23. Okay, so let's fill that information in. We have an atomic number of 11 and a mass of 23. So from there, being that we know the atomic number, if you remember, the atomic number is the number of protons. So that is going to be 11. And the number of protons also equals the number of electrons. So that will also be 11. And the number of neutrons is the atomic mass equals the number of protons plus the number of neutrons. We'll subtract 11 on both sides, which gives us 12. Okay. One more. Again, hit pause, see if you can do it on your own. All right. So now we have carbon-13. Let's find carbon-13. Carbon has an atomic number of 6 and a mass of 12. Okay, but we got to think about this one for a minute. Let's go back to the other slide. Our atomic number is 6. We had a mass of 12, but we have here carbon-13. Whenever you have a number written like that, that is this particular carbon's mass. Remember, this number here is an average. That 13 is for that particular carbon. Okay, so in this particular carbon, the atomic mass is 13. All right, atomic number is 6, which means we have 6 protons and 6 electrons. To figure out the number of neutrons, we will take the atomic mass, which equals the number of protons, plus the number of neutrons. We'll subtract 6 from both sides, and that gives us a 7. All right, there you go. That's it for today.